Oh, there's a question here which maybe I shouldn't try and address from Bhagava. Is it really possible to get something from literally nothing? Oh boy. I think I actually figured that out recently. I didn't think I'd ever figured that out. It wasn't clear it was even a question that any kind of science answer to it. Let me give you at least a rough indication of that. And that has to do with, it's related to the question of why does the universe exist? Why is there something rather than nothing? So we talk about making models of the universe. We talk about saying in a computer, we can reproduce what the universe does. But that's a little different from saying that that model is actualized as physical things in the actual universe, or at least it seems to be a little different. So we might say, and somebody was asking about simulation hypothesis, that's kind of the hypothesis that maybe we are just a video game being played by the gods, so to speak. That in a sense we are just all of our existence is just like a program that's being run by the gods on their big video game simulator, so to speak. And so I think that so there's this question of why is it that even if we have a model for the universe, which we could simulate on a computer, what makes the universe actually be actualized? What makes that model jump from being purely a model to being the actuality of the universe? Okay, so I didn't think there would ever be a scientific answer to that question, but I think there is one. And I wonder if I can explain it here. So here's roughly the way to think about it. So we might think there is a definite rule for the universe. We run the rule for the universe, it reproduces everything we see in the universe. But let's imagine instead that we were running all possible rules for the universe, all together. We might think, oh, if we're running all possible rules for the universe, how can we ever say anything about anything? Because anything possible can happen, because we've got all these possible rules. And so it's not the case so there's going to be a rule that does anything. Okay, so this is the thing to realize. That is a tricky thing. So you have all possible rules, and you start them off in all possible ways. And two rules, you might start off from some state of the universe. And then there are two possible rules you might apply to that state of the universe, and they lead to two different states of the universe. But then something else tricky can happen. There might be two other rules that you can apply, which will take those two different states of the universe and turn them into the same state. So in other words, just as you can branch in this kind of giant network of all possible states of the universe, so you can also merge. So something, when you apply all these different rules, you are taking a state of the universe and splitting it into two different possible states of the universe. But so also you could take two different possible states of the universe, and by applying two different rules, you can merge them into the same state. Okay, so they might say, well, that's kind of a trivial effect. It's not that important. Actually, that effect is unbelievably critical, because that effect entangles together what happens when you follow different rules for the universe. It leads to this giant sort of entanglement of different possibilities of what happens when different things, when you apply different rules to different possible states of the universe. And so the object that you get by following all possible rules from all possible states is this deeply tangled object that is full of sort of places where things that you thought were going to end up with something different end up with something the same, and then they branch out into something different, and so on. It's a big, complicated, entangled object. And that entangled object is sort of a thing that represents the all possible theories of physics, in a sense. Now, let's imagine that what's actually happening in the universe is it is running all possible theories of physics. That's what the universe is something which is running all possible theories of physics. Now, the question is, how do we perceive that thing? So remember that we are embedded inside that whole complicated thing. We're part of this whole thing that's branching into different, our brains as we go think about things, they're branching into all the, the actual stuff in our brains is getting branched into all these different possible histories and so on. We are part of this giant what we call rulal multi-way system of all this sort of following all these different possible rules and so on. So then the question is, let's say we're part of that. How do we actually perceive what is going on in the universe, given that? Well, this is skipping a few steps ahead, but basically, as soon as we assume that we have coherent identity through time, as soon as we believe that, as soon as we construct a way of describing the universe in which we have a coherent thread of experience through time, which is sort of a fundamental feature of consciousness and the way that we perceive the universe, as soon as we assume that, we force certain ways to look at this sort of complicated universe of all possible universes. That assumption, in a sense, forces us to look at only certain slices of this sort of universe of all possible universes. And it turns out that the slices that we look at necessarily follow the core laws of physics that we know. So that's a very non-trivial fact that has come out of our physics project, that if you start off with sort of the universe of all possible universes and you sample it as an observer inside that universe, following the same laws as that universe, then inevitably, as soon as you assume certain things, so you imagine certain things about the way that you are perceiving what happens in the universe, it necessarily follows that you will observe the laws of physics, the main laws of physics that we know. So in a sense, the question of what you have to explain then, so what we're saying is, if we take something which is following all possible rules, then it is inevitably the case that as observers embedded within that, we will perceive things which correspond to what we know to be standard physics. So now the question is, why does this universe of all possible universes, what does it mean for that to exist or not exist or whatever? So what you realize is that thing is just the working out of all possible formal facts. So for example, 1 + 1 = 2. Once you have the definition of 1, the definition of plus, the definition of 2, it is a necessary thing that 1 + 1 = 2. There's no, you can imagine implementing that by using stones and counters and so on. But 1 + 1 = 2 is something formally true. It does not depend on any instantiation as anything. So it is the case that this kind of sort of theory of physics, that where you say physics follows all possible rules, in a sense, what it's doing is every possible formal system is being, there is an instance of every possible formal system. What this big, complicated universe of all universes is the working out of all possible formal systems, which is something that does not need to be actualized. It is a merely formal thing, because all these systems, like 1 + 1 = 2 and so on, they are just abstract things. And the whole point is that to an observer who is part of this whole sort of abstract object that's being worked out, that observer will perceive exactly what we know we perceive in terms of the laws of physics, even though the thing that is there is just this formal thing that consists of all these possible formal pieces being worked out. So in a sense, what one's saying is the existence of the universe is no more than the fact that formal things are possible, the fact that you can imagine writing down 1 + 1 = 2. It's the aggregate of all those formal things, and it just turns out that as if you sort of put yourself in the middle of all of that, you, as in a sense, will perceive things which include the laws of physics. So in other words, in terms of the simulation hypothesis, where you say, are we inside a video game being played by the gods? Well, in a sense, we're inside a video game of all video games. So in other words, in a sense, all possible video games are being played, and our observation of that is something which, it turns out, as a mathematical derivable fact, corresponds inevitably to something where we perceive laws of physics as the laws of physics turn out to be. So that was a bit deeply philosophical. I'm sorry. But if you ask a question like, why does the universe exist? You can't expect anything different than something quite deeply philosophical. But anyway, I think we actually have a pretty good shot at the actual answer, which is the universe exists because in a sense, all possible formal things that we can, all possible formal things in some sense exist, and therefore it is a necessary feature of the perception of a thing embedded within this sort of set of all possible formal things that you'll get something which is like ordinary physics. Now, one consequence of this, which again, maybe I shouldn't go into in more detail, but there's a question of, does mathematics exist? In other words, you write down, you might think mathematics, oh, it's just a set of rules. We can say, we're going to choose to make it be the case that if X and Y are numbers, X plus Y equals Y plus X, and we have a whole bunch of other rules, these are the so-called axioms of mathematics. And you can write down one set of axioms, you can write down another set of axioms. You might say all mathematics is the working out of these particular sets of axioms that we chose. And in that sense, mathematics doesn't really exist. It's just something where somebody chose to write down these axioms, and so then you work out its consequences. One of the things that I've realized, and I have to say it's only in the last few weeks, is that that in a sense, if you imagine a generalized mathematics, a mathematics of all possible mathematicses, that consists of, in a sense, thinking about writing down all possible axiom systems and looking at their consequences in much the same way that I described looking at the consequences of all possible rules for physics. If you look at that thing made of the consequences of all possible axiom systems, that thing is, again, some elaborate formal object. Turns out it's the same elaborate formal object that is that thing for physics. It is the same working out of all possible formal systems that you have in physics. So in a sense, if you say physics exists, the universe exists, it's a slice of this working out of all possible rules, you have to say mathematics exists in the same sense, because it too is a working out of all possible kind of mathematical rule, all possible formal rules. So then the question is, just as we have this notion of consciousness, our way of sampling the physical universe, what is the kind of mathematical analog of that? What is it that a mathematician does that samples this kind of mathematical universe of all possible mathematicses? And what are the simplifying features of a mathematical consciousness which potentially drive general laws of mathematics? And that's the cliffhanger. That's where I am right now in thinking about this stuff. I haven't figured that out. I'm kind of guessing that in what one might call metamathematical space, the space of all possible mathematical theorems, the space of all possible results in mathematics, that there is an analog of things like general relativity and an analog of things like gravity in that space of all possible mathematical theorems, where instead of there being atoms of space that we can interpret as being physical positions in space, instead the atoms of space are like mathematical statements, like 2 + 2 = 4, for example. And that somehow that our sampling as mathematicians or something samples that space in some way that sort of reproduces the kinds of things that we experience in human mathematics.